Analysis of variance. Analysis of variance is commonly known as ANOVA. It is a collection of statistical models and their association with estimation procedures. These are used to analyze the differences among various group means in a sample. ANOVA was developed by statistician and evolutionary biologist Ronald Fisher. It's based on the law of total variance, where the observed variance in a particular variable is partitioned into compartments, which are attributed to different sources of variation. In its simplest form, ANOVA provides a statistical test of whether two or more population means are equal. While the analysis of variance reached fruition in the 20th century, antecedents extend centuries into the past according to Stigler. These were hypothesis testing, partitioning of sums of squares, experimental techniques, and additive model. Before 1800, astronomers had isolated various observational errors resulting from reaction. So they developed large amount of methods for reducing the errors. Some of the errors were reduced and some were not. The experimental methods used in the study of personal equation were later accepted by the emerging field of psychology, which developed strong experimental methods for randomization, and blinding was soon added. Ronald Fisher introduced the term variance for the first time, and he proposed its formal analysis in 1918 in his article, and the name of the article was Correlation Between Relatives on the Supposition of Mendelian Inheritance. His first application of the analysis of variance was published in 1921. It became widely known after Fisher included in his book, that is in 1925, and the book's name was Statistical Methods for Research Workers. Various other randomization models were developed by other researchers. The first was published by a Polish, and it was actually in Poland, and it was in the language Polish, which was done by Jerzy Nyman in 1923. One of the attributes of ANOVA that ensured its early popularity was computational elegance. The structure of the additive model allows solution for the additive coefficients by simple algebra rather than by matrix calculations. Before ANOVA, there were many other things that were done, but they included matrix calculations. In the era of mechanical calculators, this simplicity was critical. The determination of statistical significance also required access to tables of the f function, which was supplied by early statistics texts. The analysis of variance can be used as an exploratory tool to explain observation. For studying this, let's take an example. If we are doing a dog show, then this example is applicable. A dog show is not a random sampling of a breed. For example, you want to do a dog show, you want to know what kind of dogs I want to take. It is typically limited to dogs that are adult, pure breed, or exemplary. A histogram of dog weights from a show might plausibly be rather complex, like the yellow-orange distribution. Suppose we wanted to predict the weight of a dog based on the certain set of characteristics of each dog. One way to do is to explain the distribution of weights by dividing the dog population into groups based on their characteristics. That makes it very feasible. A successful grouping will split dogs, such as each group has a low variance of dog weights. That means the group is relatively homogeneous. The weights are almost comparably same. Second is the mean of each group is distinct. If the two groups have the same mean, then there isn't reasonable to conclude that the groups are in fact separate in any meaningful way. So we are taking mean, or let's take another mean in which each group is distinct. There are various other terminologies that are involved, and what are those terminologies? ANOVA is a form of statistical hypothesis, testing heavily used in the analysis of experimental data. As we said earlier, A test result which is calculated is called statistically significant if it is deemed unlikely to have occurred by chance. That is, assuming the truth of a null hypothesis. As earlier said, we were discussing about the type of hypothesis, and these are two. One is null hypothesis, another is alternative hypothesis. A statistical significant result when a probability is less than the pre-specified threshold justifies the rejection of null hypothesis, but only if there is a prior probability of the null hypothesis which is not high. In the typical application of ANOVA, the null hypothesis is that all groups are random samples from the same population. For example, when studying the effect of different treatments on similar samples of patients, the null hypothesis would be that all treatments have the same effect. Rejecting the null hypothesis is taken to mean that the differences in observed effects between the treatment groups are unlikely to be due to random chances. We cannot say they were deliberate. By construction, hypothesis testing limits the rate of type 1 error to a significance level. Experiments also wish to limit type 2 errors. The terminology of ANOVA is largely from the statistical design of experiments. The experimental, or the one who is doing the experiment, adjusts factors and measures responses in an attempt to determine an effect. It's a synthesis of several ideas and it's used for multiple purposes. Classical ANOVA is used for balanced data, but it does three things. That is, it's used as exploratory data analysis. It's related to ANOVA and it is a statistical tool. Additionally, it's computationally elegant and relatively robust against violation of assumptions. It provides statistical analysis. This has been adapted for the analysis of variety of experimental designs. As a result, ANOVA has long enjoyed the status of being the most useful or most used statistical technique in psychological research. Some time ago, it was said that ANOVA was not only used, it was misused. It's very difficult to teach, particularly for complex experiments. Regarding the study we have done, you have to answer certain descriptive questions. First is, what do you mean by ANOVA? Or classical ANOVA for a balanced data does three things. Explain what are the three things. What is the background of ANOVA? Describe the history of ANOVA and provide a terminology.